So my name is Michał Brunek, and I'm a student at this school, and also in my free time I do sometimes freelance programming, and I'm interested in various web technologies like Rails. Used to program in PHP, and when it comes to front end, I mostly work with React and sometimes Angular. And today I want to tell something about Relay and GraphQL, which Relay is a library which lets us create a new way of fetching data from the server to our React components, and GraphQL is a specification which is a query language which might completely change the way that a client communicates with a server. So first I want to, so the question, how many of you have some experience maybe working in React or know how it works? Okay, so most of you know, good. And I assume that many of you also are familiar with Redux, which is a very common utility library for React. And so as those of you who have experience in React know, React itself doesn't really provide a structure for building a whole complete application like Angular or Ember. The React library itself just provides a way to declare and render UI components. But it turns out that the simple idea that led to creation of React supports a completely new architecture that is very different from the MVC architecture that we usually know from other frameworks. And this architecture is called Flux. And unlike the other architectures, the data flows just one way. So first we have, let's say we have some data stores that our data is stored in. And that data is passed to our views, which is responsible for basically how we render that data on our client. And those views might start some actions, which are ways to modify the data, and those action turns are dispatched and influence, change the store, change the data that is stored on our client. And that in turn it is again rendered, and that is a simple cycle, simple way React works. As you see, the only part of the classical MVC is the view, and and the rest looks pretty different from the other frameworks. And as I mentioned, as most people probably know, React itself provides us with just the view part. It enables us to create components which display some data,
it's
but
19 hours.
Yeah, the rest, the other parts of the Flux architecture are basically up to us. We can implement them in other ways, and there were various implementations of this architecture. For example, Flux Facebook created a Flux library, which let us create actions and stores. There were also other open source alternatives like Reflux and Alt, but after some time a leader emerged, which some of you might know was Redux, which was based on a simple idea of actions being one state, and actions which modified were stateless. Basically, it borrowed an idea from functional programming that every time we pass some arguments to an action, it's executed the same way. So that way we could implement some nice features like history and hot reloading. But the problem with this Redux was that it's a pretty low-level library. It provides us with a way to modify the values in the store, but it doesn't really. We have to take care ourselves of data fetching, and we can use various libraries like JSON or like jQuery or other libraries for fetching. But So basically, the way that we fetch data from the server was not changed, and we have to take care of it ourselves. And Facebook made a completely new way, libraries that was written specifically for React and changed the way we fetch data. And it was Relay, which uses, in turn uses a new language called GraphQL, and here maybe I will introduce you to how exactly it looks. So here's an example. First of all, why is it called GraphQL, and what's exactly different about this query language? The idea is that it's supposed to model data similarly to how we model it mentally. Because first of all, we think the way we think of data is as a graph where there are various pieces which are linked. For example, when we have a user, it's might be represented as a node, a graph, and that user is linked to various posts which this user made. And here's an example of how exactly a GraphQL. On the left, there's a GraphQL query, and on the right, we have the result of this query. And first of all, what we might notice about this query is it looks similar to a JSON or a JavaScript object, and this is intentional because we might think that basically what the query is kind of like a JSON without values, right? Because the only thing we declare is what we want to fetch and what the values come later as a result of the query. So first, at the top level, we have a user, and then inside this user, we declare what fields of the user we want to fetch from the server, and in this case, we query first name, last name, and the posts that this user made. And as we see, it can be represented as a graph because first we have one user object, and then this object is linked to other objects, the posts which are nested in it. And we see that then again we declare which fields from the posts, from each post we want to query. And this is important because we cannot, we have to first, each post is not a scalar value because it post itself is an object which contains other fields. In this case, each post has the title and the content. And what's important is that we have to query exactly what we want down to each scalar. We can say that we want to query first name, last name, and all the posts, because that would create ambiguity as to what exactly we want. And in this case, we just want a title and a content, so we have to specify that exactly. And then on the right, we have the result, and the structure of the result is pretty similar to how to the structure of the query. We have first of all, at the top level we have a user object, which in turn has the properties first name and last name, and then we have an array of posts which have exactly the fields that we declared that we want. And okay, so also besides simply declaring what fields we want, we can also add some arguments to those fields, which makes those, for example, in here we have user field, and you can think of the fields that they work kind of as functions, and that simply return some values, and these arguments are kind of similar to those function arguments. So in this case, we declare that we want to fetch a user which has an ID of 2, so we pass an argument of ID, and then inside the posts, we also pass argument. First of all, that for example, we want just one post, and then we want to order of the posts we get by date. And this is how we can customize the queries in other ways. Another important feature of GraphQL is that we can split our queries into fragments. And in here, for example, in one query we want to fetch 2 users, but we cannot fetch a user twice because that would create conflict, because we cannot have 2 user fields in an object. So we say that the first user will be called user1 and the second will be called user2, and that's how we see that in the result. And then we simply fetch a user that with different ID arguments, and then we have a fragment which is called user info, and we declare that the fragment is on the field of type user, and we simply, this fragment will contain first name and last name, and then, so, for example, in this case we use the fragment so that we don't have to write first name and last name twice. We just we declare that we want the user info fragment. And fragments will be especially useful then when we will talk about how we use GraphQL with Relay. Because when we want to create a big query with lots of nested fields, we would want to split them into fragments because we don't want one giant query, and fragments make queries more clear, in my opinion. And of course, GraphQL wouldn't be a good query language if it didn't provide us with a way to modify our data besides just querying it. So in this case, in order to modify data, we create mutations, which are different from queries. And here I have declared mutations that was called create user. And I pass 2 arguments to it, like first name and last name. And then in the angle brackets, I declare what do I want to return from the query I made. And in this case, I declare that I want the ID, first name, and last name of the user. And the return will be displayed here. So the data returned will be, first of all, the name of the mutation and the data of the newly created user in this case. But of course, we cannot just insert any arbitrary queries. In order to be able to fetch something from the server, we have to define what exactly is it that we can get. And for that, we need to specify GraphQL itself is at its core is a type system. And here, I declare a type system that made me able to make the queries that I just showed you. And first of all, at the top level, I declare a query type, which is declares what I can get at the root of our query. And that's why at the root of the query, I was able to get the user field. And here I declare that at the top of the query, I get the user field that takes an ID argument, which is an integer, and returns a field of type user. And in turn, the user type, as we saw, enables us to get, first of all, an ID, which is an int, then first name and last name, and then it's, okay, I didn't really, it's not visible at the end of this line, but we are able to get posts, and we can pass optional arguments which change the way that the post field operates. So we can, the first argument is a limit, which will work as kind of a limit in SQL, which limits how many objects we fetch, and then the way we order those elements. And here I declare that we can order by date and title. I declare the specific field for it, and the field posts is of type is an array of posts. I didn't. You can see it exactly here, but I simply put posts in square brackets, and the type post has a title and content. Okay, and now you might be asking a question. Okay, so this is how we specify types, but how can I make how can I enable my server to return to be able to serve our GraphQL queries? And we need to use specific libraries for that. We need to create an endpoint in the backend which is able to return the result of those queries or mutations. And first of all, it's important to note that GraphQL is a specification. It's a type system and a query language. It's not an implementation. The implementation is up to us. And we can use, that's why we can use GraphQL with different frameworks, different backends. For example, there's a library, GraphQL Rails, thanks to which we can, using Rails, we can declare a specific endpoint which returns, which serves GraphQL queries. And in here I show an example that uses JavaScript. So, for example, if we have a server that uses some JavaScript framework to fetch, to get data, to process data. Here's how we can declare an endpoint. So first we have to declare a schema and the query type. And the query type is basically the root of our, it specifies how the root of our query will look. And so here, first of all, we declare a new GraphQL object. And for documentation purposes, we give some name to this query and a description. And then we declare what fields we can use on this query. And this is the user field, which was shown as the root field of our type system. And on this user field, first of all, we declare what type is the user field, what type does this user field return, and here I use the user type, which the declaration of which I will show later. And then we declare the arguments that this field accepts, and here this field accepts the ID argument, which decides which user I exactly use. And then the important thing is how exactly do I get this user object, and that's what. And for this we have the resolve function, resolve field, and the resolve field is a function that the second argument is the list of the arguments, the object with the arguments that we declared.
It's 1950.
The argument object has an ID field, and this can be an arbitrary function that simply returns the object that has a specific form. And let's say we have a user service object which has a get user functions which returns specific users based on the ID. And here again, we can see the whole line, but it should be args.id. So we use the argument, the ID field on the args objects to decide which users we exactly fetch. And this is the user that will be returned by this query. Then again, so how do I declare the type user? Again, I declare the new GraphQL object type, and I call this user. And again, I can give it some descriptions, and then I declare which fields do I want on this user. And first, I declare an ID field which is of type int, and I also declare that this type cannot be null, this field cannot be empty. Then I also declare that I want first name and last name on that type, and then I also want the field of type objects, and this of type field posts, and this field is of type again it's a list of post type which I can declare somewhere, and also to get those posts I need to use resolve function, which will say how exactly I return those posts. And then, for example, the resolve type, the first argument of the resolve type is the user object itself that we fetched. And then let's say I have a post service object in my application somewhere, which gets posts based on which user we get posts for. So here I pass the user, and this presumably will get me an array of posts for that user. And also we have to declare mutations some way. And declaring mutation actually is pretty similar to declaring queries. I use the same class. I just name it, for example, mutations, and then I declare a field on that mutations. The first field is the create user mutation that I used earlier, and then I simply declare what is the return value on that mutation, which object will that mutation return, and then which arguments we want to create that user. So in this case, I simply want to get the first name and last name, and I say that this cannot be empty. So and then after I pass those arguments in the resolve function, which actually realizes that mutation, I use, for example, in this case, the create user method on the user service class, and I pass these arguments that I received in this mutation. Sorry, this didn't repeat it. Okay, so now why exactly can we use GraphQL? What is the advantage of it? And the important thing is that there's less coupling between server and the client. We don't really have to negotiate what kind of response we want from the server. We can just, if we want to change the kind of data that we fetch, we can simply change the declaration. We can change the query that we get on the client side, and that changes the shape of the JSON object that we get. If we use REST, then, for example, if we add a new feature in our application, well, one feature requires some information, let's say, post with a user with first name and last name, then another feature which also requires posts and that user. We have to create separate endpoints on the backend from which we can query those. And then, for example, if we want to create a new version of our application, then we also have to create separate endpoints for that. And if we have an application with lots of features and lots of versions, the number of endpoints and the maintenance of those can really explode. But with GraphQL, we simply, if we add new feature, if we change some data that we get on the client, that we need on the client, at worst case, at best, we simply change our GraphQL queries, and at worst, we simply enhance our types and change the possible things that we can fetch on the server. The server simply declares what we can possibly fetch, and what exactly we get, we simply declare on the server, and on the client, and the server doesn't have to change for that. And actually, Facebook that's been helpful for Facebook, because Facebook has been using GraphQL and Relay for many years, even though those libraries were released just last year. and that's why it can still support the earliest versions of its mobile app, even though it was written years ago. And as you know, the features of Facebook and the fields that they can serve change quite frequently. So it's really, GraphQL can really make maintenance of applications which use huge data sets a lot easier. Okay, so now we can get to Relay, which is a framework or a library built by Facebook, which is can be used specifically in React, and changes the way in which we get data from the server. As I mentioned, in Redux, we had to make some AJAX queries, which got the data each time we wanted to fetch it. And here in Relay, we get the data completely differently. So first, I have a user component which needs some data about the user. In this case, I simply need the first name and last name. And in order to declare that this is the data that I need, I create a higher order component, which I name user. And those of you who have experience in React might know what higher order components are. And basically, I have a user component, and then I create another component which, in here, using this create container function, it fetches the data from the server, the data I need, and passes it to the user component as props. So here I execute the create container function. First I give the name of the component that I want to wrap around, and then I declare that I want to have these fragments on this component. And the first fragment is called user, and the result of that fragment will be available to inside our component as prop named user. And then I declare which fragment, which data I need, and I want the first name and last name of some specific user. And then I can use this data inside the component. And now, just like we compose components in React, we have to compose them some way in Relay. And so here, again, I wrap the user list components inside some higher order component called users list, and then I declare that I want a fragment called store, and this fragment will get us the list of users, and in each users we will get exactly the data that we declare inside the user component, and we do that by using the get fragment function on the component that we were using. So basically, each component will get exactly the data that I declared. We don't have to worry inside the components which are higher in the hierarchy. We don't have to worry about which data we pass down. We just need to declare that data right next to the component that we created. And this principle is called collocation because it means that we declare the data we need exactly next to the component that we create, and we don't have to fetch the data somewhere else. We just declare the data here, and Relay takes care of the fetching automatically for us. Okay, so here I have this component users list, and that Relay will be able to use. I need to use the root container. So first I have to declare a root, which is like the top level, declares a top level query, and the query that I need is called store, and the component that I pass to is this route. I will get the fragment called first. So back here I declared a fragment called store, which gets the list of users, and here I simply get the store fragment, and this will complete our query that we will send to the server. And in here I will render the root container and I will pass the users list components. I use the user route, so that route will get this component and will fetch the store fragment, which will be used to create query. And this is important because basically Relay composes one query that it gets from the server. We don't have to worry about data fetching. This is completely changed to how we fetch the data before, because before we got the data imperatively by executed some AJAX functions. And here we simply declare the data that we need, and the management of data, storing the data, is managed by Relay completely. So it's very different from Redux, which is very low level in comparison to Relay. And okay, this is, I hope I presented some basics of the Relay and GraphQL, and that's of course, this of course barely scratches the surface of what we can do with those technologies. If you want to know more, you can visit the site which provides the documentation for Relay, and the site which provides the documentation for GraphQL. So that's it for me. If you have any questions, you're welcome.